Don't do.
First of all, let us see what are waves. Waves are energy. And now let us see about electromagnetic waves. Waves are energy that are caused by accelerated charged particles and which consist of electric and magnetic fields vibrating transversely and sinusoidally at right angles to each other and to the direction of propagation of wave. Now there are certain points which are to be understood which are to be explained in the definition itself, like acceleration of charged particles. As we know that stationary charge has only electric field but no magnetic field, and for the production of electromagnetic wave, there is a requirement of varying electric and magnetic field. So, and if we make the charged particle move with constant velocity, then there is constant electric and magnetic field, but the electric and magnetic field is not varying with space and time. So for generation of electromagnetic wave, the required condition is acceleration of charged particles. Now let us see some of the important properties of electromagnetic waves, like transverse nature. For this nature, Hertz in 1888 uh, performed an experiment in which this is a setup what he made. Here, P and P dash are two metal surfaces which is connected to S and S dash, which are two large metal spheres, and these are connected with induction coils. Now, when there is a there is a flow of current in this induction coil, then there is a production of electromagnetic wave, which when detector is placed at some distance apart from this arrangement, then it is observed that there is some sparkling here when it is parallel to SS dash. Now when it is made perpendicular to SS dash, there is no sparkling occurred. It is due to the reason that electric field does not coincide with the GG dash, and hence it proves that it is a transverse and not longitudinal. As if it would have been longitudinal, then there would have a sparkling occurred at this condition also. So now comes to the second point, which is sinusoidal nature. Sinusoidal means the variation of this wave is according to sine wave. As we see here, both electric and magnetic fields vary according to the sine wave, and these are perpendicular to each other. This is also the transverse nature of light. This is like this, and the magnetic field like this, and the propagation of wave is in this direction. This is the transverse nature of electromagnetic wave. Now comes to electromagnetic spectrum. It is the range of frequencies over which the propagation of electromagnetic wave takes place. There are various types of electromagnetic waves like radio waves, microwaves, infrared, visible light, UV radiations, X-rays, gamma rays, etc. etc. Earlier, it was known that only visible light is the example of electromagnetic wave, but in late 19th century it was discovered that these are also the examples of electromagnetic waves. Now, these are electromagnetic waves differ only in the frequencies and wavelength, but their speed is constant. That is, c is equal to 3 into 10 power 8 meter per second in vacuum. Electromagnetic waves have particular momentum, and they have a particular energy. Now comes to radio waves. These have frequencies ranging from 500 kilohertz to 1000 megahertz, and its wavelength is 1 meter. These are used in radio, TV, and telephones, etc. Microwaves. These are frequencies ranging 1 gigahertz to 100 gigahertz. Their wavelength is 1 mm to 0.3 meter. Uses radar system, aircraft navigation, etc. Next is infrared waves. These are 10 power 11 hertz to 5 into 10 power 14 hertz wavelength, 0.7 centimeter to 1 centimeter. It is used in photography. Visible light. Their frequency ranges 4 into 10 power 14 hertz to 7 into 10 power 14 hertz. and their wavelength is 400 nanometer to 700 nanometer. These are used in laser optical fiber. Now next is UV radiations. These these are ranging from 10 power 14 hertz to 10 power 17 hertz, and their wavelength is 380 nanometer to 0.6 nanometer. Their uses are detection of invisible ink. Now next is X-rays. These are very important electromagnetic waves used in pharmacy and all. These are used to see the structures of bones and many other medical purposes. X-rays, these are ranging from 10 power 17 hertz to 10 power 19 hertz. Next is gamma rays. These are 10 power 18 hertz to 10 power 22 hertz. These are gamma rays are radiated when electron of higher energy level jumps to electron of lower energy level. Now the question arises here, why electron revolving around the nucleus in the stationary orbit does not radiate gamma radiations? It is because when the electron is revolving around the nucleus, though it has acceleration, but it does not radiate gamma rays. At the radiation of gamma rays requires some energy to be emitted. As we know that waves is a wave are the form of energy, so for the emission of gamma radiations there is a requirement of energy to be lost from electrons, and if the electron will do so, it may fall into the nucleus and the atom will collapse. So gamma rays are only generated when the electrons of higher energy level jumps to lower energy level, and we know that there is difference in energies when of electron in higher energy level to electron in lower energy level, and that is the energy of gamma rays radiated. This is Seeresh Mishra explaining electromagnetic waves, its uses, properties, and applications. Thank you.